back. I hope that everyone have this graph, this model. Okay, we have benefit of the calcium, necessity of taking calcium, negative effect of calcium. So all of these are the sub-scale or sub-component or sub-factor of attitude. And according to our hypothesis, attitude affect calcium consumption via intention. So we have the line from this tree to intention, yes. And then we have support from peer or subjective norm, also affect calcium consumption via intention. And perceived behavioral control also affect calcium consumption via intention and also directly affect calcium consumption. Before running the full model, because these are independent variable or exogenous variable. Sometimes it's called exogenous, outside, or sometimes it's called independent variable. You want to use these 4 variables to predict intention, correct? If they are together in combination of these 4 predicting intention, they have to be correlated to a certain extent. So that's why the correlation among all of them is required. Okay? This is the reason why we put correlation, why we draw the correlation lines here. Because each of them have to be correlated to some extent. Could be high, could be low. Not too high. If it's too high, we call it what? Tick tock, tick tock. Collinearity. And we have to decide which one we have to discard or delete it. Right. How many parameters to be estimated? We need to be able to calculate so that we know how many subjects do we need, right? Before you go to lunch, I ask you once you finish, please count it. So how many? Huh? No, it's more than that. Maybe your 22 is number of indicative variable, but number of parameter to be estimated. Like yesterday, yeah. Yes, please count it for me. Correct. I have to tell you correct first, otherwise you won't start counting, right? Okay. Okay. Yes, please. What are you counting? I'm sorry, I can't see. Correlation or regression or what? You're counting for variance? Okay, it's counting the line that doesn't mark 1. Okay. 29 line, okay. Then what is 29? This is 1, 2, this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then what is okay, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Then because you said 29, right? Where is it? From the output. So the output is wrong and you're correct. Is that what you said? When I give you a small factor, it's easy to count, right? But when it's big model, it's kind of a bit difficult to count. So you rely on the output, which is fair enough. But if you don't attach the data on the graph on your model, you cannot run the output. And actually, usually you will draw the model and count it first to identify number of sample and then go out to collect data. So that's why I said you should be able to count it by hands. If you cannot, or you think that because it's too big, you might, forget to count something. How can you trick your program to help you count? Do you understand my question? ถูกไหมถ้าหากเราไม่ได้ attach โปรแกรมมันรันไม่ออกถ้ารันไม่ออกเขาก็ส่ง output มาไม่ได้จะหลอกลวงเขายังไง Oh, you're a good person, so you don't know how to trick. Does it imply I'm a bad person? You built up a data file. Build up a data file? Exactly like number or variable. Say, build this up and just put any number in. Just put any number in. 5, 6, 2, whatever. Just put it in. So that you would have data file, you would have data set to attach for it to run, and then it will tell you that it's not fit. But at least it tell you how many number of parameters to be estimated. Okay? Okay, let's count. How many lambda or how many factor loading that doesn't have one regression weight attached? To make it easy, I will call this lambda. I'll call this beta, so that it would be kind of easy. So how many lambda here that doesn't have one attached? How many? 16? Okay. How many correlation? 10. Yes? Where? From here to 1, 2, 3, 4, 5, 6. So you have to start counting 10 together. Okay? 10. How many regression line? How many beta? 1, 2, 3, 4, 5, 6, 7. How many error attached to indicative variable? Because we need to estimate this error term, isn't it? In SPSS, it's assumed to be equal, but here we estimate. So how many of them? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. This one? Okay, how many? 23. Okay. How many latent variable? Seven. 1, 2, 3, 4, 5, 6, 7. รวมกันเป็นเท่าไหร่คะ So what is the total? Correlation 10. So we have 10. Okay, you expect me to calculate it for you. 10. Correlation, again, correlation 10. Plus lambda 16. Plus regression 7. Plus this D. How many D? So that 18 plus 4. 18 plus 4. Are you with me or not? Plus 7. 62. Like that. This one. Should we count this one or not? Yes, you have to count it. There's 63, right? Then have a look here. It's 63, right? Have a look here. What does it say? It means that at the when we draw original model, we come up with 63 parameters to be estimated. But computer tell you that no, I cannot run it. This part is model identification specification. I cannot run it because you have too many parameters than the number of equation that I have to calculate. You have to fix to put some number so that I will reduce the number of parameters to be estimated. Okay? This is sometimes the problem that you face. And how are you going to fix that? Have a look here. I decided to put the variant here 0. I asked the computer not to calculate the error term of this one, and then I run it again. But my question is it possible that I put 0 in here instead of here? Or I put 1 here, 1 there, just put any number to fix it? Is it possible to do that? No. You have to think. My question is, why do I put variance equals 0 here? I asked the computer not to calculate the error term here. Why? Okay. When I use benefit 1 or benefit 2 or benefit 3 to measure benefit, I write the equation, right? And then I know that this indicative variable can explain benefit to a certain extent, but it cannot explain all. So there must be some error, must be calculated. But here, calcium level is not the same as benefit. I measure the amount of calcium. So what I did is just I measured the amount of calcium. I only categorize it so that my data will be normally distributed. But my calcium level should be able to explain 100% of the calcium level, right? So even though I classified it into level, but this classification come from real number. So these two should be equal. These two should be the same. Actually, it's the same set of data. One presented in real number, real figure, one in groups. So my calcium, my amount of calcium, should be able to explain 100% of the latent calcium. Are there any error if they're able to explain 100%? No. That's why I said variant equals 0. This is one technique or tactic that you use to deal with latent variable when you have only one indicative. Sometimes you end up having only one indicative variable. Explain this later. Then ask the computer not to calculate the variant explain. Okay? Now, what happened if I run it? Then they said, not for the model. I can run it now, no problem, right? And when I come here and have a look, you can try to do it together with me. Look at here. This become 1.00. This become 1.0011. So that means I tell the computer that these two are actually the same. Does it make sense? Yes. So we're able to count the number to be estimated. And if you're not sure, because the model is big, write or developed a data set and attach and ask it to run. Don't care whether it can be run or not, but it will report you how many number to be estimated. That's the technique. The second technique that I tell you now, how to fix the problem if you don't have enough equation to calculate your parameter. There are several techniques. This is just one example. A lot of this problem can be found in IBM Knowledge Center because this is the program of the IBM. You go to IBM Knowledge Center and then you will find all the questions on the answer. What next? What next? The next step. Now we know our model can be run. What next? Model specification. So this now we specify and found that it can be run. Identification and then checking how we're gonna remodel, right? What should we do? Have a look here. But what does it tell you? Now, this is about the regression weight. What do you see? Let's see from here. No reason why I have to see it from the bottom, but I'll just enjoy doing it this way. Have a look here. The intention, the construct intention. These stars mean what? Significant. It means that the regression from intention 1, 2, 3, 4 to the construct intention significance. It means that these 4 indicative variables can be used to measure the latent variable intention. Correct? In statistic term, we say that it's achieved what? What type of validity? Achieve not construct. When you look at the regression line and the significance of the regression line is the convergent validity. Oh, okay. Yes. The significance of the line from the construct to the indicative is suggests that that construct has convergent validity. What about this construct? The same. Good, right? This one, this construct is good. So when you look at each construct, looking good. But this is the problem. The line from perceived behavioral control to calcium, not significant, right? We want to identify factor affecting calcium consumption. It tells you that this is not significant. So what should we do? Yeah, why not? Because it's not significant. That's what it tells you. Let's do it. Save it first. Okay? Be prepared to say goodbye to this line. 1, 2, 3. Gone. Run it again. Estimate model fit. How fit it is. Yeah, looking good, but what else? The line from benefit to intention not significant. The line from negative effect to intention not significant. But the line from necessity of intake calcium to intention significant. Well, it agrees with the theory. Remember? Because the theory said, I think you're too full. Maybe you have too much lunch. Theory said attitude toward calcium consumption affect intention. We have 3 dimensions of attitude. This benefit or this factor is the attitude toward calcium consumption or attitude toward calcium. This one, A or B. The benefit of taking calcium, the benefit of calcium. So, is it the attitude toward calcium or attitude toward the benefit of taking calcium? Of calcium. So, does it hurt if I decide to remove that line? No. But does it hurt if I remove this line? Yes, because this is the only construct that is talking about the attitude of behavior toward behavior. Yes? ใช่ไหมคะใช่ไหมคะข้างหลัง Yes? So, here. Yes, the computer tell me that I should remove this line. The regression from negative effect of calcium to intention. And I go to recheck with the theory, and it's relevant because theory tell me that the attitude toward behavior affect behavior. But this is not the attitude toward behavior. It's the attitude toward calcium itself. So, yeah, statistics tell me the same thing as the theory tell me. So I'm quite confident to remove that factor. Okay? Okay? Once you remove this pathway, you have to remove this construct as well. Otherwise, the computer still recognize as something exists in the model. Run it again. Can I remove this line? Benefit to intention, benefit of calcium. Yes. Benefit of calcium. Have a look here. Wow, everything's looking good. Right? This is less than 0.05. Significant. So it means that all the regression line in the model are significant. So what left in my model is only factor that is significantly affect intention. Intention also affect calcium. This is my final model. And I've done it this way. And so my hypothesized model is confirmed or not? When I answer, when I conclude, when you propose, this is your hypothesis. And then you run your model. After you finish running the model, you have to answer the quick research question. The findings show that the data fit the model, say well or good or moderate, whatever, and it's confirmed the hypothesized model that these three variables affect intention. Oh, sorry, affect behavior via intention. Okay? Norm chi-square less than 3. It indicates that you achieve absolute fit and you also achieve construct validity. The word construct validity mean in this sense because the construct doesn't mean this factor or this factor. It means the whole construct here. This whole construct or this structure achieve validity. The AGFI greater than 0.9, good. CFI greater than 0.98, good. Very good. RMSA, root mean square error, less than 0.05, good. Perfect. So I'm happy that my models fit. Should I finish it? Why not? When I'm happy, I can't finish it. Let's go and recheck. Now we know that all the pathways are significant. Model fit? Yes. Model modification in this indice. Are there anything I can do to improve my model? The program suggests me to draw the line from error 3 to error 4 and then my model will improve E1 to E2, E1 to E3, D16 to 18. Lots of suggestions. Should I do it? I have already achieved the fit model. Good fit. There's no need to improve it anymore. But if I want to, there, for example, there is a correlation between E3 and E4. Have a look here. E, where is my E3? Okay, E3 and E4 here. Okay, 3 and 4 here. Let's read the question. Intention 3. I try to consume sufficient food containing calcium or supplement to meet 800 milligram. Intention 4. I intend to select food containing calcium or supplement as much as I can. These two items are likely to have the same when are likely to be correlated, highly correlated. You have to go back and review. Yes, those who answer 4 here are likely to answer 4 in that question. Those who answer 1 in that question likely to answer 1 in the other question. But if you don't see that pattern and you can't find any literature review to support, then there is no need to draw the correlation between here and here, even though the computer said if you do it, everything's looking better. No need to. Furthermore, we have already achieved the good fit. No need to do it. Okay? What else should we look at? Yeah, I heard something. What else should we look at? I haven't asked for the residue, so I have to ask and run it again. Perfect. We have to ask for residue. Good. My standardized residue covariance should not exist, should not be greater than 2.5. Happy? Are you with me? What does it mean? If the absolute figure of the standardized residue is not greater than 2.5, it means that these three indices measure how valid the indicative variable used to measure that construct. This is yesterday, right? So here, it means that all the indicative variables remain in the model are good to use to measure the construct in the model. It also another evidence to imply that this is a good fit model. It's also implied that you have achieved the construct validity, right? Done. If this is, if you want to know what factor affecting calcium consumption, this is your answer. SM means structural model. Here, I summarize that when you perform or when you conduct structural equation modeling or structure model, you don't really need to find the reliability. Why? You don't have to find the reliability when you construct the whole model. Why not? Why don't you have to? When you perform a factor analysis or when you develop the scale, you need to find the reliability because you want to know whether each of these indicative variables are correlated and actually measure the same factor. But here, for the whole model, you don't need to measure the reliability. Why? Right, right. Yeah, you're correct. Because you're not developing a scale. You want to know whether this variable actually affect this variable. So what your concern is whether the regression between this x to y significant or not. Don't do everything that you can do just because the figure's there for you to calculate. You have to know what you need to calculate, okay, or what you need to report. The next step, actually, once you have the final model, you have to do what we call cross-validate. Have another group of sample and use that group of sample. So you will have another file, another SPSS file, which have the same set of data, but collect data from different group, okay? Attach to the final model again and run and see whether you get similar result or not. And if it is, then you say, yes, my model are validated, has already validated and it's validated and I'm quite confident that this is the model used to explain the behavior because I run it 2 times and I still get the same result. Okay. Any questions so far? No? Say it again. Sorry. But here, the hypothesized model and the final model is not the same. You just say that your final fit model doesn't confirm your hypothesized model because it does not. It does not actually. It doesn't confirm your hypothesized model. Instead, we only found that. Okay. So because you have to answer yes or no. The same as when you do other statistic. You want to compare, are there any difference in the score, the math score between boy and girl? And then you answer whether difference or no different. The same. If your hypothesized model look alike, look exactly the same as your final, you said that the hypothesized model is confirmed. But if it look different, you just say that it's not confirmed. And the actual model based on the data that you have is like this, and explain it. Okay. Now, if I want to know that, this is the last bit, bear with me. I want to know whether this model can be used to explain the behavior of male and female. Another word, the same model can be applied to explain the behavior in male as well as female or not. How do I do that? In conventional analysis, not in AMOS. Think about it in conventional analysis. If you come up with the multiple regression and then you have final multiple regression, and you want to know if this model or this regression is the same for male and female, what you have to do? You perform subgroup analysis, right? The same here. If you want to know that the model for boy and girls are the same, you perform subgroup analysis. But in AMOS, we do not call it subgroup analysis. We call structure invariant testing. We want to test whether the structure for male the same as structure for female. And we use the chi-square test to assess if the structure for male the same as structure for female, the p-value of the chi-square should be less than 0.5 or greater than 0.5. A greater, B less than, C don't know, greater, why? Yes, I have to confirm your answer first. Yes, it should be greater. Why? Why? When we test the significant, we test the whether it's different significantly. If it's the same, then the difference is not significant, isn't it? This is the same idea, right? How do we do that? Right. Let's do it together. This is the technique in AMOS. Let me skip this. I found that it's too difficult to understand. In AMOS, they call it multi-group analysis. Let's say here, my research question said, does gender modify the structure of the proposed model? In other words, structure for male is the same as structure for female. This, keep this handy. Keep this aside because this is a technique. Go to analyze, go to manage group, name the group, attach the file, analyze, and read the output. Okay, let's do it together. So, have everyone go to this point yet? ถึงตรงนี้หรือยังคะ Okay. What my lecture say? Go to analyze here. Analyze here. Go to analyze. Okay. Then what? Manage group. Read this handout. Go to analyze. Manage group. Okay. In my data, in my set of data, if the sample is male, I give the letter one, sorry, the number 1, female 2. Okay, so I'm gonna name my first group male. And new. Let's do it together because I don't want to lose you on the way. And then group 2 is what? Female. And then close. Okay. Next what? Attach file. How to do it? Select file to attach. Have a look here. Now when you have, before that we have only one file that we work with, but now it tells you that we have 2 groups. But we're going to use the same file, right? The file that we work, the data file that we work with is 710 for SEM, correct? Yes. But we need to tell them what variable that we want to compare to do the subgroup analysis and what value for male and what value for female. Okay? Click grouping variable and looking for gender and okay. So gender appear here and then tell them, they said click group value. And then they said, well, in your file, you have 2 variable 1 and 2. So you have to remember what is your 1, what is your 2, But I have already tell you that yes, male is 1, so I click 1 and okay. Do it again with female. With female, we have to attach the file first, which is what? 7. Okay. Attach group name, gender, group value to okay. What next? What next? Go to analyze, then choose and then this will appear. Actually, it asks you what you want to compare. You want to compare the measurement weight, you want to compare structure, you want to compare this and that. Maybe this is too deep, but trust me, the default is okay. Okay. But actually, what you want to compare is the measurement weight. You want to know whether each regression is the same because you want to know this factor affect this in all this X affect intention or not because you look at the regression. So you look at the measurement weight. This is enough. Just click OK. Look here. Everything's here. And then what? Oh, looking good. Calculate. And everything become okay. Then what? Then you have to read the output. What does it mean by okay? It's okay only mean that yes, it can be run. What are we doing now? We compare the model, right? So where is the output that we have to read? Correct. At least you know where to go to read. Perfect. What do we read? This is what you have to report. We want to know whether the regression from each X, from attitude, norm, perceived behavior control to intention, and regression from intention to calcium consumption in male is the same as in female. So what you're checking is the measurement weight. And it showed that the two models have the regression weights different or not different? Not different. What does it mean, not different? It means so no different means the same. The same means so we are playing 20 equations. The model can be used to explain the calcium behavior both in male and in female. Are there any variants in the construct? Variation. in the construct? No. So, in terms of intervention, now you have to write a discussion. You found that this model used to explain the calcium consumption, and it can be used to explain the behavior of male and female. So, in terms of intention, do you need to provide separate or different intention for male and female? The same intervention can be used for male and female because the same factor affect their behavior. That's how you use it in your research. You use the data to discuss, to propose the intervention. Any questions so far? Happy? You want to do this by hand? Ajahn, if the program can help us to do it, well, we have to do it by hand, right? Actually, you can do it by hand too. So we're done with this. Okay. This is the last portion that I want to tell you. Now you know how to run your structure model in AMOS, but AMOS cannot be run if you have missing data. So if you have missing data in your original data file, you have to treat your missing data first. How do you treat your missing data? Say if I have 1,000 subjects answer my questions, some of them will answer some questions. Say I have 100 questions, some will answer some questions, some not. That means maybe this person missing this question, maybe this person missing this question. Should I delete all those subjects who not answer all the questions? I might end up delete everybody, right? How do I know which subject I should keep, which subject I shouldn't keep? I have to check the pattern of data missing. There are two types of missing. One is missing completely at random. The other one is missing at random. What the difference? Completely is what? Okay. When you look at your data, the first thing you have to do is, let's say if you have 100 questions, how many questions that person answer? If the missing is more than what, 25% in general, okay, in general, if the missing is more than 25%, so 1/4 of the question hasn't been answered, deleted. Too many missing. But if you say no, I couldn't delete it because I don't have, I might end up not having, then you check. But if you have enough, more than enough, 25 is too much, I would delete that first. Sir? No. If you don't have any intention to perform the invariant testing, just only the variable in the model. And then the remaining access for MCAR and MAR, go to SPSS, Go to analyze, missing value analysis, and expected, and use this method to estimate the expected maximization to replace the missing value. You should also, not you can, you should also test for the type or the pattern of missing as well. This is what we call the little test. The name of the test is the little test. Little M-car test. Okay. The hypothesis is that the null hypothesis, say missing occur at random. The alternative is missing not occur at random. Here, I found one. I found one reference that is very strict. Like I usually use 25%, but this reference said that if it's more than 2%, better not replace, just delete it. This is very strict. 2 versus 25. Mm. Okay, I don't have. Sorry that I can't show you because all the data that I gave you already been um estimate for the missing. But if you have missing data, that's what you have to do. Sample size. Sample size again. We've been talking about sample size every day. Yeah, because one disadvantage of SEM is that it's require large sample size. 3 types of formula can be used to estimate the sample size. Subject to variable, this is easy to count because you just count only what? You just count number of indicative in your model and then you know how many. Counting variable is easy, but counting parameter estimates is a bit difficult. But which one should you go for? Should you go for, say, if you have the choice of subject to variable, choice of subject to parameter to be estimate, or formula which take anticipation of effect site, which formula or which type of formula that we should go for? 2, why? Yes, I forgot to say yes. Yes, 2, why? Yeah, look at how AMOS look at how AMOS analyze. They count number of parameter. The program counts number of parameters to be estimated, and if you don't have enough equation to estimate, then they say, well, it's not enough because their calculation, it's calculation based on number of parameters to be estimated. So it makes more sense to use this formula. What would be the ratio? 1 to 5, 1 to 10, 1 to 20, 1 to whatever? The ratio. 1 to 5 is said to be the minimum. 1 to 20, not maximum, but good, which is a lot. A lot of people say maximum because that's a lot of subjects. Then in statistic book, it suggests 1 to 10 because 1 to 20 is good. That's preferable, but it's going to be too many. difficult to find, use a lot of resources, and also when you apply for ethic approval, the company would also ask you because it's a lot. You disturb people, your potential participant, right? They will ask, is it possible to reduce to 1 to 10? And a lot of this one paper reporting that they've been checking, reading the published paper that use structural equation modeling to see which formula that researcher use and what the ratio. And it said that the common ratio that being published is 1 to 10. But it doesn't say that this is good. But he said that yeah, this is what he found. A lot of people use 1 to 10. This formula usually used when you think that the nature of your question or the nature of your data is likely to be skewed. It's not normally distributed. It's hard to find, like, how do I say, like satisfaction. People tend to answer 3, 4, 5 rather than 1, 2. So it is unlikely that your data will be normally distributed. Or if you use different technique, like you have multi-level, multi-stage sampling, and you have the effect of different level of sampling, then you might consider this technique. But you don't know. This is the guesstimate. You don't know. It's hard. You will know after you finish running the model and you see how your data behave. You will see it later on. If you decide to use this formula, you just guesstimate what you will see. You don't know. This would be good if you want to do it second time. You do it the first time, and this is what you found, and you said that well, maybe it's better to use if I'm gonna rerun or redo the model again to validate. I'm gonna use different formula to calculate for sample size. I'm gonna consider effect size. That would be more appropriate. I also give you the reference to make your life easy so that because sometimes it's very difficult to find a reference. At least follow this reference to find the original reference if one day you want to use it. Is that all the reference? Done. Any questions so far? Perform confirmatory factor analysis of intention. The latent variable intention contains three indicators: intention 1, intention 2, intention 3. Use that 710 SCM file to attach and run it and see what happens.อ๋อเลยเพลงกระทะได้ค่ะค่ะค่ะสุดท้ายไปเบรกแล้วมาทำอันนี้แล้วก็หมดแล้วค่ะพอยสุดท้ายที่จะบอกเกี่ยวกับ SEM Okay, after you run it, this is what the program report you. Chi-square equals zero point 0, degree of freedom 0, and probability cannot be computed. Estimate model fit. It cannot be computed. It cannot be computed. It cannot be computed. It cannot be computed. What does that mean? Or what should you do? How are we going to solve this problem? Model indice. Usually we go to modification indice to see what the program suggests you to do. No suggestion. Your program not happy. Why? This is one problem with AMOS, and you have to be aware. If you're gonna construct single factor which has less than 4 indicative variables, it cannot be run. So if you want to construct measurement scale or single factor, one scale to measure something, you should have at least 4 questions for AMOS to be able to run. Okay? But get this point? If I add one more here, it should be okay. Yes? Okay? That's one thing you have to be aware of. But why here? Go back to the last model to compare. Alright, open. Mm. Why this model can be run even though benefit have only 3 factor and necessary have only 3 factor? Yeah, because when they count number of parameters to be estimated, they count the whole model. So that's why it's more than enough. But let's say if I want to use only factor benefit to do something else, like I want to conduct another study and I want to measure the people attitude toward the benefit, and I'm going to take this factor and I say this scale has been validated and I'm going to use it. I have no evidence to convince because it's valid when it's combined in combination with other two. Okay, so that's why I say that before putting everything, every portion, every bit into the model, check it, clean it, make it as an cells. If you want to use it for something else, you can just take it without worrying that I cannot because of this, because of that. If you know this limitation beforehand, before you develop your skill, then it will make your life a lot easier when you develop the full model. Yep. Any questions? How well, since you don't have any question, I ask you here. How well or how many percent that attitude toward calcium consumption, peer and perceived behavior control able to predict intention? How many percent? That how many percent that the combination of attitude toward calcium consumption necessity, peer and PBC predict intention? 67%. Yes. In SPSS, this is an R square, right? When you read it, it's on top of that latent variable. How many percent? Oh, I'm sorry. I should delete this one and run it again. Yeah, 0.67. Hmm. How many percent intention can explain calcium behavior? Only 6%. Very small. Hmm. Well, if you go to read, it does say that when people have the intention, then if they have barrier, then the intention will not go to behavior. But if you have supportive environment, then intention will affect behavior. What is the indirect effect of PBC on calcium consumption? PBC doesn't affect calcium directly, but it does affect calcium indirectly via intention. What is the size of the indirect effect of PBC on calcium consumption? Hmm? Yes, correct. Okay, you can do it yourself or you can ask the computer to do it for you. Ajahn, if the computer can, why you ask me to calculate, right? It's the job of Ajahn to torture student. Click it, and then it will tell you. So if we calculate point, standardized indirect effect is 0.11. Yes. When you times 0.49 with 0.29, something like that. Its report both standardized indirect effect and indirect effect. Unstandardized. It reports both. If you want to know the indirect effect without unstandardized, you just click here and then use this figure, which is the unstandardized weight, to calculate. Completely finished.